So in this video, we will basically talk about a process called process of successive magnification, right? It is part of the number system chapter for the ninth standard CBSE syllabus. Okay, what is successive magnification? See, magnification is magnifying something, making something large enough so that we can see the details, right, which are inside very clearly, right? So what does a magnifying glass do? Magnifying glass magnifies a particular object. It projects that object in a slightly in a larger frame, so that we are able to see. If somebody has got some problem with the eyes, they use magnifying glass to see smaller letters, because smaller letters will get magnified and they will be able to clearly see the letters. Okay, so this is what magnification stands for. Now, successive magnification is nothing but you are applying this philosophy of magnifying something. Okay, you are successively magnifying something to locate a particular number in the number line. Let us take an example. 2.667. This is what you have to locate in the number line. Okay, so take the first decimal point, 2.6. Where does 2.6 lie? It lies between 2 and 3. Okay, so you draw a number line in your notebook, right, where the starting point is 2, the ending point is 3. Okay, now divide this line into 9 equal segments. So the first segment you will call it as 2.1. The second segment you will call it as 2.2. Third segment 2.3. Fourth 2.4. Up to 2.9 you will define. Okay, because 2.10, the moment you talk about 2.10, that becomes 3. Okay, so you leave it there. All right, so you have 2, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, 3. Right. So where does 2.6 lie? 2.6 lies between, right, 2 point, we said we have to look at 2.667, right? So where does 2.66 lie? 2.66 lie between 2.6 and 2.7. Okay, in this number line, 2.66 lie between 2.6 and 2.7. Now further you magnify, right? What do you mean by magnifying? Now you draw another number line with 2.6 as starting point, 2.7 as the ending point. Now again divide it into 9 equal segments. You mention the first one as 2.61, 2.62, 2.63, 2.64, 2.65, okay, up to 2.69, and then the final thing will become 2.7. Okay, the moment you add one more unit, it becomes 2.7. So now you have 2.61, right? 2.60, 2.61 upwards up to 2.70. Okay, so where does 2.66 lie? It lies between 2.667. Where does it lie? It lies between 2.66 and 2.77. Now further you magnify. You draw another line, okay, with 2.66 at the starting point and 2.66 as the starting point, and so 2.67 as the ending point. Okay, now you again divide. So what happens? 2.661, 2.662, 2.663, etc. up to 2.67. Okay, so you will be able to clearly locate 2.667, right, in the third iteration. So this is what we call it as successive magnification, or the process of successive magnification. All right, there is one more aspect that you will have to look at. There is a way of finding square root of any number, right? If x is any integer, you can find square root of x in a geometrical manner. Okay, so let us assume we will first evolve the general formula. Okay, so let x be any number. So we will have to find root of x. Okay, so what you have to do is you have to draw a segment of length x, right? Draw a segment of length x. You call the segment as AB. Okay. Now extend B by 1 centimeter. From B, you extend the segment by 1 centimeter. You call this endpoint as C. Okay. So you have AB and you imagine that this is of length x. Okay. And then you are extending B by 1 centimeter. Okay. That is BC, right? Which is 1 centimeter. All right. Now find O, which is the midpoint of AC, right? For this AC segment, find the midpoint O. How do you find out? Take a compass, right? Take a length which is more than half of the segment called AC, right? Keep in A, draw an arc. Keep in C, draw another arc. Keep in A, draw an arc below. Keep in C, draw another arc. Now connect these 2 points. You get the midpoint of AC. Okay, these things you have studied in your earlier classes, right? So if you have any doubts, you have to go back and revise that chapter before proceeding with this topic. All right. So I have O, which is the midpoint of AC, right? Now what you do, right? OA is a radius, isn't it? OA, is a particular length, right? What is that length? So you have, it is the midpoint of AC. Okay. So AC length is x plus 1. So OA is x plus 1 by 2. Now keep OA, right? Take the length of OA using compass and draw a semicircle. All right. Draw a semicircle. So if you look at it, when you take OA length and draw a semicircle, it will end in C as well. OC is also a radius of this semicircle. Okay. So now you have drawn this semicircle. From B, right? In the AC, you have B, right? From B, you draw a perpendicular, right? Touching the semicircle. Okay. And then you call that, that point where the perpendicular touches the semicircle as D. Okay. Now connect OD. Right, this becomes a right angled triangle, right? So OD again is a radius, right? OD is the hypotenuse of this right angled triangle called OBD, and OD is also a radius of the semicircle. So what would be the length of OD? It is x plus 1 by 2. Okay, so let us consider what is OB. Okay, so the entire length of OC is x plus 1 by 2, right? BC is 1 centimeter. Hence OB is equal to x plus 1 by 2 minus 1, which is equal to x minus 1 by 2. Alright, so the base OB is x minus 1 by 2, hypotenuse is x plus 1 by 2. So what is the altitude? Now apply Pythagoras theorem. Hypotenuse square is equal to base square plus altitude square. Right? Hence altitude square is equal to hypotenuse square minus base square. And what is hypotenuse square? I have x plus 1 by 2 the whole square minus x minus 1 by 2 the whole square. Okay. So here, in the denominator, 2 square is common. So take it out. So you have 1 by 4 into x plus 1 the whole squared minus x minus 1 the whole square. This is of the form a squared minus b squared. Okay. So what is a squared minus b squared? A plus b into a minus b. So you get 1 by 4 into x plus 1 plus x minus 1. You get 2x multiplied by x plus 1 minus x plus 1. You get 2. Okay. So it becomes 1 by 4 into 2x into 2, which is nothing but 1 by 4 into 4x. Now cancel out the 4. So you get altitude square equal to x. Hence altitude is equal to root of x. So BD, the altitude is root of x. So this holds good for any value of x. Okay. So if you have to find, if somebody is asking you to represent root of any number in the number line, all you have to do is draw this geometric diagram. Okay, let us say phi is root of phi is what you have to find out. Take 5 centimeter, draw it on a piece of paper, extend it by 1, find the midpoint. Okay, draw a semicircle, and from the 5th unit, draw a perpendicular to the semicircle. Measure this length. Okay, measure this length, take it to your number line, draw an arc, that is root of phi. Okay, you can basically check it out, that will be root of phi. So we have in our classes, we had asked lot of students to try this out for smaller integers, because on paper, right, you can only go up to 10 centimeter or 12 centimeter, right? So beyond that you cannot actually draw and see it. So we have tried this experiment for smaller numbers, and it has worked very well. So I strongly suggest you try it out for some examples, and you will find the results to be really amazing. And this will be an interesting exercise to be performed at home. Okay, so in our next video we will talk about one more aspect of the rational numbers, and with that we will come to the end of this chapter. Okay, so if you have any doubt, please email us at askmentorguru@gmail.com. all right, okay, so let's wait for our next video. All right, thank you.